Good morning, good afternoon. This is Mohammed Kharma. I will be presenting this paper on behalf of myself and Professor Adel Al-Tawil. Our paper title is Threat Modeling in Cloud Computing, Literature Review. The impact of weaknesses and vulnerabilities are increasing significantly. Especially with the continuous increase in the cyber attack. As per to the statistics, cybercrime can penetrate 83% of companies' network. Also, as mentioned by the security executives, they said that they are not prepared enough for the threats that lie ahead. On the cloud area, the rapid increase in the cloud computing adaptation result in a wider attack service and rise in cyber attacks. Moreover, the modern cybersecurity toward the cloud computing system are too diverse based on the nature of the cloud computing platforms, and the traditional security measures is not easy to manage and cope with this diversity. Our outline, we will be talking about the background in cloud computing and threat modeling areas. After that, we will be talking about the research and review, which included into our literature review. And after that, we will be talking about the conclusion and challenges. Application threat modeling as defined by Vlahos and Murana as a strategic process aimed at considering possible attack scenarios and vulnerabilities within proposed or existing application environment for the purpose of clearly identifying risks and impact level. According to Shostak, threat modeling is the use of abstraction to aid the thinking about the risks. Another important definition about the threat modeling is according to Sean, which is commonly used by Ozonov. Threat modeling is a process that can be used to analyze potential attack or threats, and can be also supported by threat libraries and or attacks taxonomies. So if we want to define the threat modeling, it also can be defined as an attack. Threat modeling is the attack model understanding by formulating a thorough going view through analyzing the environment, assets, and processes and actors from outside to inside, inside to outside, and inside to inside perspective to model the necessary mitigation measures. So what we meant by outside to inside. So the inside to outside, we refer to the external adversaries that have no legitimate access to the trusted boundaries of the environment, such as, for example, the outside of the model data center, vehicle, smart home, or computer system. The inside to inside is the insider adversaries that have legitimate access to the trusted boundaries of the environment, but they use their privileges to attack the environment assets. The third type is where the insider adversaries that have legitimate access to the trusted boundaries of the environment, and they use their privileges to initiate the attack from the inside of the environment toward an external environment. Yeah, so let's give some quick definition for the cloud computing, because it's the domain of our research here. So as per to the National Institute of Standard and Technology, NIST, Cloud computing, as a definition, a pay-per-use model for enabling available, convenient, on-demand network access to shared resources or pool of configurable computer resources that can be rapidly provisioned and released with minimal management effort and or service provider interaction. According to Mill and Grants, there is a couple of characteristics for cloud computing that every researcher in the security and threat modeling need to be aware of. The first one is the on-demand self-service, where without the need of communicating with the cloud provider or service provider, the customer can directly provision the computing resources as needed automatically. The second one is the broad network access. So in order to enable the usage by different tools such as mobile phones, tablets, capabilities are made available through the network and may be accessible at or by the conventional protocol. The third one is the resource pooling and enabling the multi-tenancy. This represents having more than one user who share the same computing resources, storage services. The next one is the rapid elasticity. This is a crucial aspect of cloud computing, and it donates the user flexibility to scale up and or down of the resources based on the demand at any point of time while he's using the resources. And this is risky characteristic where the environment is not static, where it's dynamically changed based on the demand. The last one is the measured services, where monitoring, controlling, and reporting service utilization, which allow and support the transparency between the service provider and the user of the service. From service model perspective, the cloud computing, there is different service models according to Bawaya. The first one is the infrastructure as a service, where in this model, the provisioning of virtualized resources happen on demand. And we refer here to the infrastructure level. So we are talking about the computing, storage, and communication. The second one is platform as service, which is PaaS, offer its customers platform development so they may create and maintain their application and the cloud-specific utilities. The third one, software as service, which is the SaaS, refer to the top level of the cloud stack where application reside. Here is a quick example about the each level or service model. So for infrastructure, we are talking about, so for example, the EC2 instances or services from Amazon Web Services, which provide virtual machines with configurable tools in a similar way how we regularly manage the physical servers. The PaaS, there is, for example, the Red Hat OpenShift, which is a widely used PaaS service. For the SaaS or software as service, which is, for example, the email clients or the email like Gmail or Yahoo mails beside the social media networks websites. Also here about there is a quick comparison between the layers which covered or being covered by each service model compared to the legacy approach of managing the environments, which is the on-premises environments. Here, in order to have better understanding for the threat modeling in the cloud computing, and this is applied for different domains as well, not only for the cloud. We need to understand different aspects, basically for. The first one is can be addressed by first question, which is what are we building, which usually depicted through a diagram. So basically, for example, we are building a web server that, for example, connected with a database and hosted over application server, or connected with end clients through their agents or browsers. The second question, which aims to identify threats. So the question is, what can go wrong? So by this question, we can assess the environment and in order to identify the threats. The third question that we need to ask as part of the threat modeling process, which is that what are we doing to defend against threats? So here is the mitigation for these identified threats in the step 2. Finally, which is the validation. So we need to answer this question, which is have we acted on each of the proposed or previous steps? So by this, we can cover the whole cycle of understanding what we are building, identifying threats, and mitigating these threats, beside ensuring that we actually mitigate these threats. So in this research, we did a classification for the included studies as part of this literature review. So in the identified approach and method are categorized into 2 types. Based on one factor, which is for these research that are modeling language based, and for those that are not. The selection of this criteria or categorization is because using a modeling language is an essential part of a threat modeling framework that can address formalization and automation challenges in the modeling of threats. The approaches that built on modeling language have added characteristics, including higher scalability, applicability, and adaptability, and support for improvement on top of the threat modeling specifically for the automation and integration with the cyber threat intelligence platforms. Here we will be talking about some of the included studies as part of this literature review. So the first study here, for example, is concerning about the design phase and the software development lifecycle, and their approach was based on Stride with Tasco as a modeling language. There is some their contribution, basically, they considered the threat-driven security policy enforcement and successfully provided a Tasco-based technique to assist the architects throughout the modeling process by helping in identifying potential threats on the solution deployment model and guiding the user to select possible abstracted mitigation function that map into the concrete implementation and automatically injecting the relevant security network functions into the deployment model. So this is the added value of this one. Also, their method involves 6 steps, with the main involvement of the architects for part of it, and other part is with the security expert before the deployment model, because this is important to select and make sure that the mitigation for the identifying threats is correctly understood and selected. The second article included in this study focused on evaluating and identifying risks and threats in the cloud broker system. The author in their article provided a threat modeling schema, attack tree, and attack graphs, and data flow diagrams were created using their threat modeling schema to show the link between the security threats that have been identified, and they presented a method for determining acceptable scores using the Common Configuration Scoring System, CCSS. The fourth study by Chung, it was in the quality aspect of threat modeling languages. They developed a technique to rate the effectiveness of the language, and they used a previous language created by them as well called enterprise lang, which is a language for modeling threats in enterprise application to demonstrate the verbose method use. So the author developed test cases to verify the enterprise lang intended behavior in order to validate it. The tests demonstrated that enterprise language attack simulation behaves as planned. Additionally, these attacks and their mitigation are accurately represented. Another research is which was coming from the Brozok, which is based on the OWASP ontology-driven threat modeling, ODTM framework, which is a set of means for implementation of an ontological approach into automatic threat modeling of a computer system. What is the ODTM framework? This is a framework that enables formalization of security-related knowledge in terms of architectural component and associated threats and countermeasures for different computer system types or domains. One of them was the cloud computing as well, in form of domain-specific threat models and ontologies based on the web ontology language format. Also, they highlighted the fundamental challenge with the threat modeling or in threat modeling, which is the difficulty of formalization of and automation adaptation on this field. Therefore, in order to enable this formal method in threat modeling, the author focused on the ontology-driven framework that they proposed, which depend on the threat modeling for a specific domain, and extended for other domains beside the data flow. Also here, some of the studies that wasn't based on the language based. So what we just mentioned before in the previous two slides was about the threat modeling language-based approach. Now we'll talk about the other modeling approaches. In this slide, we see the first article proposed a cloud-specific framework by implementing a threat intelligence framework to analyze and monitor the live stream of cloud logs using Splunk, with monitoring or with mapping to meter attack framework matrices based on the conducted experience and findings by them. They showed how threats can be mapped based on the attacker behavior, depending on the meter attack framework and the cloud systems. The next study here is by Scott. He argued about the maturity level of the threat modeling, and in spite of the systematic processes of STRIDE, which were introduced like 8 years ago, the state of the practice, according to his article, was remained only ad hoc and depending on the whiteboard hacking. So this is trigger the point or the question about the maturity level of threat modeling process. So the author suggested five maturity levels of for threat modeling, which are influenced by the maturity levels or models such as COBIT and CMMI. They proposed these levels, these 5 levels, which the first one, initiation, defining the process, managing and measuring for the process, and optimization or optimize the process at the level 5. So here we will be talking about the observed threat modeling challenges. The first challenge in threat modeling is the lack of comprehensive threat modeling language toward or in the context of cloud and security. So here, redesigning the modeling language to enable the existing language based on the STL guideline. On the quality aspects, creating test cases to improve the testing coverage percent, which will result in a better threat modeling quality. The second challenge is about the lack of standard cloud computing threat modeling artifacts that can be used or be a base for next work, for example. So the threat modeling of a cloud computing component is important to be covered using threat modeling language that is capable to cover the threat modeling needs. In addition to extending one of the existing ontology-driven framework, for example, which enable the formalization and then the automation for the threat modeling. The expected outcome of such modeling is to address one of the main challenges with the threat modeling, which is the difficulty of formalization and automation adaptation in this field. The next challenge is the about the maturity level for the threat modeling process, and in what really happened in the real world when practicing the threat modeling process. The next challenge is about the need of methods to verify and validate the generated threat model artifacts. So we ensure that these models are comprehensive enough and covering the weaknesses or the vulnerabilities in the system. So here we come to the conclusion. So the main findings in our paper here revolve around the increasing interest in adopting threat modeling in cloud computing. The second one is about the observed limitation throughout the reviewed research is the lack of end-to-end automated threat modeling framework that can improve the accuracy, provide a prediction, make a recommendation, reduce the manual work, and cope with the elasticity nature of the cloud, which is a main difference between the on-premise deployment or environments and the cloud based on the cloud characteristics. The research direction are toward formalizing or formalization of the threat modeling, including its quality assessment, risk assessment, threat modeling automation, and besides this, to enable the reuse of the artifacts of threat modeling that created one time to use it in another case within the domain of cloud computing. So to produce abstract threat modeling for a cloud and extend it for environment specific or implementation specific, and to use basic schema for cyber threat intelligence. Thank you very much.